I really love the way Saul Khan explains exponential notation.
Big surprise. Whoop.
Seriously. If you have any doubts, you really need to take a bit of time and go right through the lot of them. Look under exponential notation in www.khanacademy.org. Saul breaks the concepts down for you.
How?
Well, he starts by explaining that the addition concepts bring us to multiplication concepts. And that helps us to see that when we multiply, say 4 times 4 times 4, we can call it 4 raised to the power of 3.
Very powerful.
Powerful indeed. Multiplication concepts bring us to exponential notation concepts. What about some of the rules? Let's go through them. Feel free to stop the tape and write them down.
Will it change?
No, math seems to stay pretty much the same at this level.
Cool.
Okay, rules. First, you always need to remember this. The number that looks larger and is on the bottom is called the base. The tiny number floating up in the air is the exponent.
Big base. B and B. Got it.
And you need to know the language.
Spanish. English. Hebrew.
No, math. When I say 3 raised to the power of 2, that means 3 times 3, or 3 squared. 3 is the base and 2 is the exponent.
5 raised to the power of 3 means 5 times 5 times 5.
Excellent. Now, here is a rule. Anything raised to the power of 0 is 1. Say the base is 3. If 3 is raised, we call it to the power of 0. The answer is 1.
Got it. Anything raised to the power of 0 is 1.
Now, when 0 is raised to any power, it equals 0. 0 is the base. Say, 0 is raised to 4. The answer is 0. Just remember what we are doing. 0 times 0 is 0, so it follows.
Okay, I have it. The 0 is big and anything floating on top still keeps the answer 0. Even if both are 0.
That is an interesting one. And I'm just going to say that the answer is 1 for now. The alternating sum of binomial coefficients from the nth row of Pascal's triangle is. Anyway, no higher math right now.
I want to learn higher math.
Brilliant. And you will. In due time. You can Google math fun facts for more on that.
So what else do you have?
The number 1 as a base is another interesting case, and a good one to write down. If you take the positive number 1 to any power, it is always 1. 1 is the base. Put any positive number in the exponent and the answer is always 1.
Easy.
And if you have the number -1 and raise it to an even number, you will also end up with a positive 1. So now here is the secret. If you have a -1 and raise it to a power that is an odd number, the answer will be -1.
I lost you. It is all odd.
Let's do an example. What is -1 times -1?
Well, a negative number times a negative number would give you a positive number. So the answer is +1. -1 raised to the even number 2 gives you a +1.
And what about -1 times -1 times -1?
We start with a negative times a negative, so we have first a +1, but when we multiply that by a -1, we would end up with a -1. So an odd number of negative numbers leaves you with a negative, and a -1 raised to an odd number gives you a -1.
Yes, exactly. This rule is helpful if we are given a very large number and do not want to multiply each one out. For example, what is -1 raised to the 1000 power?
That would be +1.
And what about -1 to the 1001 power?
-1.
Why?
Because the -1 is raised to the power of an odd number.
Great job. Now let's look at a negative exponent.
The exponent is the small number floating, right?
Yes. When you have a negative exponent, Saul Khan says, it is the same thing as taking the reciprocal of the base and then raising it to the positive exponent.
Yeah, right. What are you saying?
You need to know your definitions for this. The base is the big number. What is the reciprocal of 2?
That would be 1/2, or 1/2. You just flip it. Reciprocal is a little confusing.
I know, right? That one got me in a chemistry class. It just means to flip it. The top or numerator becomes the bottom or denominator in the fraction.
Now that we have the reciprocal, what do we do?
Let's look at a simple example. We have 4 to the power of -2.
So, we just put the 4 under the line, making it 1/4. And we change the sign of the exponent to +2, right? I looked at 4 as starting as 4/1 to make it easier to see.
You rock. And we have 1 over 16, from the 1 over 4 to the power of 2.
How about 1 over 2 and the 2 is raised to the negative 3?
1 over 2 to the negative 3. You tell me.
I would bring it to the numerator, like 2 on top, and then change the negative 3 to positive 3.
And what is your final answer?
Well, 2 to the power of 3 is simply 2 times 2 times 2, that is 8. My favorite number.
Excellent.
I will go practice the problems then, and I will look at my notes.
I'm rooting for you.
Thanks, Teach.